correct? So any questions from there?
So decile analysis.
Okay. See, the idea about decile analysis is, as I said, that it can be used as a two ways. One is validate your model, and the second one is first one is validate your model. The second one is identify the best cutoff, and here when I say best cutoff, using some statistics like case. Okay, and once we have that one, and we can also use a business implication if we take a specific cutoff. So this is the idea behind this one. So for doing a decile analysis, what we need, so for example, training data. Okay, so you have a customer ID. For example, if you take customer ID, your actual bad flag, I mean, maybe in our case it's a default, and probability of default. So this is the output. This is my actual, this is my output. Okay, for example, you have like this, and what we are doing is actual is, for example, some of them are ones or zeros, something like that. You have it. Now the probability of default, you may have 0.5 here, 0.2, 0.15, 0.6, 0.7, 0.15, 0.4, 0.8, 0.2, 0.1, something like that. You get the. So what we are calculating, we are calculating the decile. So based on what? Based on the probability. So what I'm saying is, give me my top 10%, I'm calling as a 1, second top 10% I'm calling as a 2, third top 10% I'm calling as a 3, etc. For example, in our case, the 0.7 is belongs to decile 1, or 0.6 probably decile 1, and this can be 2, this can be 2, this can be 3, this can be 3, this can be 4, maybe like this 5. So in our case, what we are saying is, of course, like this, what we are trying to get it is decile. By each decile, once you know the decile, by each decile, like 1, 2, 3, 4, 5, etc. And I can calculate the number of ones, and I also calculate the number of zeros. Okay, so for example, in our case, in my topmost decile, how many ones are there? So you have 2 ones. So any zeros you have it? No. And second top, second decile, how many we have? Again, 1 and a 0 here. And so like this, you are calculating.
So 1, 2, decile 0, 1.
Yeah, this is 0, this is 1, right?
Decile 2, there is 1, 0.
That's what I'm saying. Oh, sorry. Yeah. So like this, you can calculate the number of ones and number of zeros. So decile 1 means what? It has a high probability in our case. So high probability should have a higher number of ones, less number of zeros. So the second decile means what? Second highest probability. That means that if the probability of default is low, that means you should have lesser number of ones compared to first decile, right? So like this, you should get a descending order of number of ones. So this should be in descending order. You should get it. And am I getting that one or not? That is what first thing I am looking at. So for example, my decile 1, I have 100. This is a 90. This is a 65, and this is a 45. This is a 1. 15, 20, 15 or 10 and 5, something like that, you got it. And here, for example, each subject, each a decile have 150 observations, for example. So 150 observations you have it, 50 here, 60 here, 85 here, and 105 here, and 135 here, and 140 here, and 145 here, something like that, you will get it. Correct? This is a, suppose each decile have, suppose total is 150. Correct? So this is what exactly I'm calling as a this one. So in terms of this one, number of bats, how many? Number of bats are approximately, you have 330. Number of goods are, so this 720, and this one is so 1050. So what is the percentage of bats you have overall? The bat rate, 330 by 1050, for example. This is my percentage of bats. So now bat rate, what I said, bat rate is each decile wise how much bat rate you have. So this is what you got it. And the bat percentage, that means that in my first decile how much bats which we captured, bat percentage. What is bat percentage? The bat percentage is this divided by 330. Right? So this is what bad percentage we say. So good percentage, 50 divided by 720. Out of total goods, how many goods you captured in the each decile wise? This is what the good percentage. Right? So cumulative bad percentage. That means that, okay, in my first decile you got like this, and my first and second decile, how much bats you got it? And the cumulative good percentage. This is a cumulative good percentage. And the Ks value, what we are saying is the cumulative bats minus cumulative goods. So this is the, and whichever decile you are getting the highest Ks value, and that is your maximum Ks. So the Ks equal to maximum of out of all these things, which is 50%. So, and if I take a cutoff, the cutoff is I'm taking a third decile. Okay, in even third decile also, you know the minimum probability and maximum probability. And so, for example, minimum probability is 0.8 here, and maximum is 1, and 0.6, and 0.8 here, 0.5, 0.6 here. Suppose like this you have it. And what is the minimum probability here? The minimum probability is 0.5. So you can take, since I'm getting a third decile maximum differentiation between the zeros and ones, and I can decide that accordingly cutoff is 0.5. Why? Because the Ks is giving you the maximum differentiation between zeros and ones, and that is the minimum probability of the third decile is 0.5. So that's how you will take cutoff. So as per the rank ordering, it's satisfied. Is rank ordering is satisfied or not? And the Ks value should come first 5 deciles. So that's also coming. This is in the third decile. and the cutoff also you will decide 0.5. Suppose if I take a 0.5 as a cutoff, and if I take a third decile as cutoff, how many customers, how many good customers you are predicting as a bad? 195. How many bad customers you are predicting as a good? So are you fine with that? So that's the place the basic business decision making will come into the picture. So if your model is good, your topmost deciles will capture maximum number of ones. Your model is not good, you will not able to capture maximum number of ones here, and some of the ones you will also have here. So that is the reason the model is good or not. By looking at the decile analysis also you can say that. So this is I have done it for training data, but the same thing I can do for testing data also. Can I do or not? The testing data also I can do that. So once I get the training data and testing data, is my bad rate is similar to my testing data versus training data. So in my first decile, am I getting 67%, similar in testing and training? And that is what I need to look at. And not only that, the KS is coming in the third decile. There also should get KS as either second or third or fourth. It should not be too much difference between the, and the KS value you are getting here 50, you should also get a similar kind of value there also, right? And how did you calculate the lift? My first this one 67% you're able to do divided by 31%. So this is the lift for, of course, if I remove that percentage, if I make it as generic number, and so this is my lift is 2.1 times. And suppose if I take lift for first two deciles, what is the lift? How can we calculate? Sum of my ones divided by 330. That is my bad rate. Sorry, 300 divided by what? 31%. Correct? So this is my lift for first two deciles. Lift for first two deciles. The top 20% of the data, how much you are able to capture the number of ones with respect to where I compare with the randomly chosen sample of 10% customers. So randomly chosen 10% of customers, you will have a probability of default is 31%, but whereas here you are getting approximately 62% or 61% if I compare overall. Is it clear now? So the lift. So basically we'll compare bad rate and the KS value, compare, and the lift. So these are the three things you will compare between train and test by each decile. If all are coming similar, then your model is satisfied, and you can also identify the cutoff. So this is what I explained in the decile analysis part. Is that clear or not? So you will have this data and you will calculate the deciles, and once you get the decile, you will aggregate the table based on these things. You can calculate from these three, and these are all our formula based stuff, which I just now shown you.
Chandra,
Online guys, any questions?
Chandra, I have a question.
Should the volume of testing data and training data be same?
Not necessary. So the training data can be, have 70%, and testing data can be 30%, and it can be anything. Generally we take 70-30% because we generally give a more data for a model building purpose, because you need to identify the patterns. For testing time, you will have a little less data.
Is there a way we can limit the accuracy?
There is no way. If that is possible, and there are a lot of softwares you can come up by this time, right? There is, one important thing is there is no fixed model. You may get one model, I may get one model, someone will get a different model, because the way you are treating your variables. the way you are including or excluding the variables, right? So the model is also not fixed. And if model is not fixed, then how the accuracy can be fixed? It's not possible.
For instance, for example, you could a very accurate model, right? But let's say due to some privacy concerns, you cannot show that much. You need to limit it to a certain number. Let's say you have 80-85% of the max accuracy you can possibly arrive at this model because of the privacy concerns. I'm talking about healthcare. Is there a way we can, let's say you get about 90%, 95%, can we just, is there a possibility we can reduce the accuracy of the model?
See, I don't know the practicality why we need to reduce the accuracy. See, there are two reasons generally the accuracy will get high. One is some of the variables, some X variables is a derived variables of your Y variable, or maybe the Y variable is a derived variable of X variables. Sometimes in that kind of situation, you might see a 95-99% of accuracies. So that kind of situation, first of all, you need the identifying the variables itself is wrong, right? Because you cannot use derived variables of X or derived variables of Y, in any of the form. So that is something which you need to take care at the time of inclusion of the variables in the model. And if you are getting a model accuracy is high, there are some reasons in healthcare or a banking kind of a clients. So there are certain variables they should not include because of the some regulatory compliance. So for example, in US kind of a scenario, you cannot include a gender. You cannot include some kind of religion kind of a thing as part of the model variables. The reason is, based on the gender, you cannot differentiate giving the loan or taking the loan, right? So based on the gender, based on the religion, you cannot differentiate the people. Okay, which religion is good customer, which religion is a bad customer. You cannot differentiate that. So that's the kind of scenario the banks has to take care of this kind of a thing before implementing the model, because all these models will pass through some regulatory body, a regulatory committee. So if they identify that these variables used part of the model, then that model will not be approved. Does that make sense? So like that, some of the regulatory environment, you cannot use certain variables, though those variables will give you high accuracy.
So you're saying that in case you get high accuracy, dropping a variable could possibly reduce?
Yes, of course. End of the day, the model accuracy is coming from where? From the variables. So the model accuracy, if someone is talking about, it's a purely data preparation and the data aspect.
But is there a way to identify which variable could give you
it is a purely, that is the place, yesterday, I was referring that the variable reduction techniques. So, and univariate analysis or bivariate analysis, when we are doing, if you remember the univariate regression, there itself you will get to know which of the variables are highly influencing your Y variable. And not multicollinearity, multicollinearity within the X variables you are looking at. I'm talking about between your Y and X, performing a logistic regression. So you remember yesterday I was, explaining that concept, with the help of univariate regression, calculating the so much D for each variable, right? So that itself is talking about, okay, which variable is, high influencing on your Y. Any other questions, guys?
So there one question.
Yeah.
So you did the bad rate calculation. Bad rate is not only being used in the lift calculation, not in KS, right?
Lift calculation, of course, and at the same time, you also need to understand the bad rate is giving a decreasing order trend, because that is what I was looking at.
Okay.
Because you cannot look at the absolute number, because in the training data you have 150 observations, your testing data probably you may have 50 observations.
Okay.
So then I cannot use 100 versus 50 comparison, right? So that place, the bad rate will be in terms of percentage, you can compare it.
Okay. And next question, Chandra. So why are you considering 0.5? Why are you taking the minimum probability? Should not it be 0.6? Because till
No.
0.6.
So basically what I'm saying is if 3 and above,
Uh-huh.
I'm saying that 3 and above, I'm saying that the bad customers, and 4 to 10, I'm calling as a good customers. And when will I get 3 and above? My minimum probability is, I mean, if I take the cutoff is, 0.5 and above, then only I will get the 3 and above customers.
No. Please come again with good and bad customers. What did you say?
So I'm saying that the cutoff is basically, I'm deciding that wherever case is coming.
Mm-hmm.
So from this, the first 3 deciles I'm calling as a bad customers, and
Okay.
4th to 10 I'm calling as a good customers based on the KS where I'm getting the decile.
Okay.
So that means that if I want to use this as a cutoff, I cannot use, I mean, if I want to use the decile, I can use the decile, but the decile is not a best way to identify the cutoff. So what is the corresponding decile? How did you get this decile? The decile you got is between 0.5 and 0.6 probability, I'm calling as a decile 3.
Correct.
So 0.5 and above, I'm calling as a bad customers, right?
Okay. Yeah.
So that's the reason I'm taking the cutoff is 0.5.
Okay.
The minimum probability of a decile where I'm getting the high KS value.
Okay. Sure. Got it.
Any other questions?
Again, isn't this supposed to be based on the risk appetite of the bank?
That's the reason I said the third important aspect when I look at, I was explaining this one in the beginning. So the decile analysis, the business implication if you take the cutoff. So that's what I was saying, that this is a statistically, you can say that this is a 3 decile is a third decile or a 0.5 is a best cutoff. But are we ready to take that much risk or that much, losing the customers? So for example, if I'm saying this one, I'm losing these many customers. I mean, these customers are actually good customers, but you are predicting as a bad customers. And these customers actually, they are bad customers, you are predicting as a good customers. So are you ready to take that much risk around this? So that is what I'm saying, that the business implication, if we take that as a cutoff. Is it correct or not? So that's what I said. The decile analysis is not just meant for comparison of this one. A lot of times this will also help you to a business decision. Perfect. Okay, so I think if you are clear with this concept, I think see, a lot of times the banks will use the decile analysis very frequently, especially when they decide the cutoff. So the decile analysis is very key thing in as part of output.
Once again, explain the significance of that lift.
The lift is, I was referring that what? The lift is basically, suppose if I'm taking the model at an overall level, suppose if I take a customer, what is the probability of that customer become bad? We have 31% of bad customers. So I can say that the risk associated to that customer is 0.31. It's a probability of default. But I'm saying that if I take a top 10% of customers, what is the risk associated to that? 67%. So that means that I'm prioritizing the customers. I'm trying to say that these customers are high risk customers. How? Because my top 10 customers, if I take, the probability of default is 0.67. Correct? So that means that how many times you are able to improve in terms of the riskiness? It's a 2.1 times, because it's a 31% here and your bad rate is 67% here. 67 by 31 is somewhere around 2.1 or 2. Whatever value comes into that.
So I was saying for every increase in decile, that is amount of risk customers are able to eliminate.
It is not that. I'm saying that I'm trying to increase the riskiness. That means that these are high probability of default customers. But how much you are able to improve in terms of the model perspective or in terms of the differentiation perspective, that is the lift is talking about.
So is that represented in terms of what value? Just 2.1?
It's a 2.1. 2 times you are able to improve. A 2.1 times you are able to improve the risk. Yes, Prarana.
So these ones and zeros are on these actual target variable, right? And the
I think this is
probability.
what yesterday you also asked, right?
Yeah, I'm still confused. So
I told you this is a very clearly I mentioned in the beginning itself. And my
yeah.
customer ID is this. This is the data, and this is my default, and this is my probability of default.
Okay, yeah, sure.
And based on that, I calculate the deciles based on the probability.
Probability. Okay, thanks, Chandra.
Okay, cool. I think if you are clear with this, so the classification problem we solved with the help of logistic regression. Okay, the next type of problem is segmentation. So what is segmentation? So I think if you remember the type of segmentation, the segmentation problem is nothing but we don't know how many groups you want to form, right? So classify the data into n number of groups based on similarity. What does that mean? If I get n groups, if we get n groups, within the group there is a similarity, between the groups there is a dissimilarity. A simple example, you are classifying the customers into 3 segments. Okay, maybe affluent customers, mass affluent customers, or mass customers. So this is a very common segmentation done in any kind of a customer-centric industry, especially banking or telecom, etc. What is this affluent customers? Maybe they are maintaining high balances. This is a medium balances or a low balances. So generally, maybe a 5% of customers are maintaining high balances, which is greater than 2 lakhs. And maybe 25% of customers are maintaining between 50,000 to 2 lakhs, and remaining 70% of the customers are maintaining the balance of 50,000. So based on what is the similarity within these groups? The similarity within the group, on an average, in this group, everyone is maintaining more than 2 lakhs balances. That is the similarity. And what is the similarity within this? In this group, the customers are maintaining the balance of 50K to 2 lakhs, right? And what is the difference between these 2 segments? The balances itself. That is one of the key thing. But sometimes, okay, in this case, the affluent customers, the majority of customers are coming from, for example, suppose majority of customers are coming from North region. Okay, the majority of customers are coming from West region, or this is the South and East region. What is the similarity? I'm saying that, okay, so these customers are, there is a similarity. Most of the affluent customers are coming from North. Most of the mass customers or mass affluent customers are coming from West. That is the similarity, right? So this is what I'm saying, that whenever I'm classifying the data into n number of groups, the groups should have a similarity within that, and between the groups, we should have a dissimilarity. If I'm able to come up with that kind of a groups, then we call it as a segmentation. So this process of getting groups called segmentation.
The scope of similarity can be more than one parameter.
Yes, that's what I said. That's the reason I said in this case, this is a balances, and this is a location. So I mean, you can see that with these two variables also you identified the similarity, right? Of course, you may have some more. So majority of, maybe a gender-based thing. For example, majority of customers are male customers. Here, a mixed customers. Here, female customers. So that means the females are maintaining the low balances. That is the similarity. Are you able to follow me?
So ultimately, you will classify these customers into just 3 groups or multiple groups or based on problem.
I just give an example of 3 groups, but you may have n number of groups. That's what I said. The n is I don't know how many groups you want to form. So you may come 3 groups, you may come 5 groups, you may come 10 groups. And that's the reason the solution for segmentation is not unique. When, for example, you may come up with the 5 groups on the same data, but someone can come up with the 6 groups because that's how they see that there is a differentiation.
What are the number of parameters? The cluster may be not good in shape.
We'll talk about that part. The what is the problems while we are implementing that is we'll discuss. But I'm talking about the definition of segmentation, a definition of the segmentation process. So are you clear? What is the segmentation? Any questions? Okay. So typical classification of segmentation. So what do you mean typical classification of segmentation is? The segmentation broadly you can categorize into 3 groups or 4 groups or 5 groups, different situations. But I'm saying that maybe classification 1. So the segmentation, there are 2 types of segmentation. You can see that one is objective segmentation, one is a subjective segmentation. So the objective segmentation is nothing but when you have your target variable, and subjective segmentation is a no target variable. So a lot of times when I say target variable means what? Y variable. So if you don't have a Y variable, we call it as a subjective segmentation. When you have a Y variable, if you do the segmentation, you can call it as a objective segmentation. But yes, majority of times, whenever I'm referring to the segmentation, most of the time the segmentation is, I'm referring to this one. Is that clear? Any questions on this? Okay, so that is the objective versus subjective segmentation. And the second is heuristic segmentation versus scientific segmentation. What does that mean? Heuristic means based on the business rules. Based on the business rules, you will segment the, just like a business rule like this, balances. Based on the balances, I want to segment the customers. So in this case, am I using a scientific technique? No, right? So based on the balances only, I'm saying that, okay, if anyone is maintaining greater than 2 lakhs balances, I'm calling the affluent customers. So how did you come up with the 2 lakhs? It's a business rule. So that is what I was talking about. Here, there is no technique as such. This is a pure, a business understanding, a business-driven approach. And the scientific segmentation is based on a scientific algorithm. Right? There is some statistical algorithm, some kind of algorithm you will use to divide the data into groups. Does this make sense? So this is another classification you might see. So in this kind of scenario, when we are referring to the objective segmentation, so if you say that any technique, so if you remember objective and the subjective and the business, I mean to say that heuristic versus scientific. So objective is, there is a technique called value-based segmentation or a life stage segmentation. and the subjective is like RFM segmentation, and the scientific decision trees can come under objective segmentation, and the scientific like a k-means cluster analysis, k-medians, or a spectral clustering, or heuristics, sorry, hierarchical segmentation, or a DB scan. These are all different techniques for a scientific algorithms. Okay, are you able to follow me? So now let's understand these are some of the techniques which are very popular in terms of the heuristic, because a lot of situations, though these are not a fixed rules, but at least you should understand the approach, understand the methodology, what is the typical heuristic approaches will take. So a lot of times the segmentation used for a market, customer segmentation, it's very common, is customer segmentation. Sometimes we do segmentation like a store segmentation or a branch segmentation, or some situations location segmentation, I mean geographical segmentation, product segmentation, or some situations like this. You do the segmentation at a different level. It depends on your context. Suppose a customer segmentation is very common, especially in the marketing and sales perspective. So it's very common, in the marketing perspective, it's a customer segmentation is bread and butter, right? Because the entire strategy of reaching to the customers or offering the products, the product development, there are so many aspects based on the customer segmentation. A simple example, which is very common approach, for example, if you think about Apple iPhone, are they targeting every customer in the market? No, right? So they are targeting to a specific set of customers. What is their product? What their expectations? What kind of money they can spend, and what are their expectations with respect to product usage, service usage, etc. And they are also designing the products to specific to that group. But whereas a Samsung or Nokia, what is their target? They want to target maximum number of customers in the market. So that's the reason they come up with the different products. So each product is meant for one specific segment. Correct or not? So that's how the strategy, the marketing, channel marketing, reach, spend. There are so many aspects, based on the customer segmentation. And I think it's very common that the cross sell, upsell, what channel I should reach out to them. There are so many aspects we will do based on segments. And the store segmentation. Okay, this is very common in the retail sector. In the retail, basically, which of the stores are performing good? Which of the stores are spent? What I can say that which of the group of stores are selling set of items more? Like for example, a stores in a particular location, they sell certain items very high, and which of these stores, they are selling combos, right? So based on certain aspects, you want to segment them so that you can manage your inventory, you can manage your supply chain, you can manage your store timings, which you can manage a lot of things based on the segmentation. And branch segmentation, for example, this is very common in the banking or any kind of a branches if they have a distribution network, etc. So the branch segmentation is something a lot of times the sales people you want to set set the targets. In that kind of situations, for every sales people in the bank, you cannot give a same target. Certain branches have a high scope, certain branches have a low scope. So you need to identify which of the branches are having some high scopes so that you can set the target, similar kind of targets for those branches. So that's how you do that. So like this, the segmentation is applicable to many situations. Of course, I'm explaining that the few situations, but out of that, the customer segmentation is very much popular. In healthcare, and especially the pharmaceutical industry, again, the segmentation is very popular, especially the doctors, grouping the doctors, what type of doctors, what type of prescriptions they provide, and how to reach out to them, and what kind of implications if we don't reach out to them. So there are a lot of analysis you can do, especially in the healthcare sector, especially the pharmaceutical industry. And even a healthcare perspective, even the other side of that, the claims, healthcare insurance perspective. So the claims is, you want to identify which of the customers are high fraudulent claims they will supply, what is the characteristics of those groups. So you want to segment them based on the fraudulency and based on the characteristics of customers, which of the segments can be more fraudulent, which of the segments can be less fraudulent from the existing data. So there are a lot of things which we do, but out of that, the customer segmentation is very much popular. A lot of times we use this one. So when I say customer segmentation, the data will be at a customer level. Correct? So when I say customer level means customer ID and of course a different attributes of customers. So like for example, demographics and behavior. What is the behavior? What is the behavior of the customers in terms of the product usage, in terms of the channel usage, in terms of the web usage, in terms of the customer care usage, in terms of the other service usage, right? So there are the behavior aspects, and of course, the other aspect is the contact. So the contact information, because at the end of the day, once you apply the strategy, you identified these customers are really good, but you don't have contact details. What is the use of that, right? So typically you will have this information, and when I say the behavior is the biggest role plays, to understand the differentiating the customers in terms of the behavior, right? So this is one thing, and of course, customer segmentation very common in the market segmentation perspective. What do you mean market segmentation? Suppose you want to enter into the new markets. For example, a particular company is really successful in the India and they want to enter into a market like Singapore, because the behavior of Singapore customers and Indian customers might be different. So you want to really understand whether you are going to be successful there or not, or if you want to be successful, what type of offering I should do that. So that's the kind of scenario. First, I need to understand who are my customers in Singapore. What is the scope for my product to be successful there? So then what we do is a lot of times we do the survey analysis and we analyze the survey, and we will understand that, based on the survey analysis, we will identify what is the percentage of customers which we can target. Who are my customer and who are my then we will do some competitive intelligence, and then we will come up with the differentiating the products, and then we will launch the product. So there is a lot of process involved before launching a new product in a new market, right? So that's also a kind of a customer segmentation only. But yes, in this case, you're dividing the entire market into 5 groups or 10 groups or 20 groups, whatever it is. Does this make sense? So in the first level is the heuristic segmentation. So of course, as I said that there are so many different ways you can perform heuristic segmentation, because it's a purely business driven segmentation, but a few of them are very commonly used in the market, in the industry. One of the segmentation is a value-based segmentation. What do you mean value-based segmentation? So you will divide the data based on certain metric, certain value. So either it can be revenue, it can be a profit, it can be in a volume, number of items you purchase. Maybe you can take maybe a CLTV, customer lifetime value. So based on certain things, you will predict. You will segment. So a simple, like you remember we discussed about based on the balances maintaining by customers, you divide into affluent customers, mass affluent, and mass customers. How did you do that? In this case, based on the balances. Okay, greater than 2 lakhs, between 50K to 2 lakhs, and less than 50K. So this is what the done. So this is a one type of segmentation related to value-based segmentation. Okay, even if I don't know what cutoffs I should take it, but that kind of situations, if you don't know the cutoff, which one to take, decide, then you can perform like a quartiles, quintiles, deciles, or a pentiles, you can take it. So okay, so I have a customer data and I have a balances. I will divide the data into 5 groups or maybe a 10 groups. Does that make sense? If I take a 10 groups, what does that mean? So that means you are getting the 10, I mean deciles means 10 groups. That means each group is one segment. Or maybe if you take a quartiles, you have a 4 groups. Right? So that is what we can take. So typically what I'm saying is you have a customer ID, for example, revenue generating by each customer, and I can come up with a decile, and each decile we call it as a segment. Decile is nothing but segment. Something like that, you will get it. Does that make sense? So this is what we call it as a value-based segmentation. So based on a certain value, you will divide. Of course, a lot of times this will gives you a lot of business sense. Who are my customers? Who are generating my maximum revenue to me? Who are generating a least revenue? So where to focus more? So how to increase the value, the revenue overall. So for that, whom to target first. So a lot of prioritization, a lot of understanding about your customers, etc., can be done with the help of the value-based segmentation. Are you clear on that? What is the value-based segmentation? And once you have that, you need to understand, okay, if someone is generating high revenue, what are the characteristics? If someone is generating low revenue, what are the characteristics? Right? So that when I'm acquiring a new customer, I will acquire the customers with the characteristics of generating high revenue. Does that make sense or not? So that's how you will do a lot of things. So for any things, the segmentation means first, once you get the segments, identify the characteristics of each segment. Identifying the characteristics of each segment, and this is what we called as a profiling of customers.
So what segments identify based on characteristics, or is it vice versa?
No. First we will divide the segments based on the value in this case.
Yeah, value is the factor
which we know. And once we understand that, okay, these are my top decile customers. Top decile means high revenue generators. So now what are the characteristics of these high revenue generators?
There is no guarantee that they will all have similar characteristics.
No, there is no guarantee, but this is the place you will have high proportions or maybe something like that. So for example, I know that my first segment is 80% of customers are my male customers, for example, or maybe 90% of customers are coming from a specific location, or 95% of customers are started with the product called item with the maybe any item they purchased, maybe like a phone. So that means that if someone is purchased phone first, that means that there's a possibility of that customer become a good customer. So the characteristics help you to understand who are my customers. The profiling is extremely important. So we will talk about that when I'm showing that one. So I'm saying that the profiling is something which we do the segment first, then we will understand what is the similarity within the segment and what is the dissimilarity between the segments. Of course, similarity, you know, within the segment, the value is one similarity. Between the segments also, the value is dissimilarity. For example, my first decile, the average revenue is coming 1,000 rupees, for example. And second decile, the average revenue is coming only 600. That itself is a difference. Does that make sense? Okay, so the second type of segmentation, which is very common in this one, is a life stage segmentation. So again, the life stage segmentation also, it's a kind of a based on some variables which we target. In this case, it's a very common is life stage means what? Which stage of life you are at? Which stage of life a customer is at? And based on that, I understand that if a customer is in a different life stage, they have a different type of behavior. If you are an end customer, your behavior is different. If you're an employee, if you are a customer at a married customer, your behavior can be different. So that is the underlying theory when we are referring to the life stage segmentation. So even the customer value-based segmentation on this also comes under objective segmentation. So what is the objective in this case? The revenue, which I give an example. In the life stage segmentation also, the objective is, it's also an example of objective. How? Based on your demographics of customers, especially the age and the gender and location. So these are the three characteristics, based on, I think these are the typical, or maybe sometimes we also use a marital status. So based on these variables, you do the segmentation. A simple example is, let me take age. Suppose if you take a less than 20 years, you are at a what stage? Maybe more, you are at a student stage. At 20 to 24, it's a typically you have started employment. This is a typical range, or maybe 25 max. And 24 to 20, maybe a 30, this is the stage of started married. It's a kind of a marriage stage. At 30 to 35, you can say that it's a started family, maybe having kids. This is what typical age the people get kids. And 35 to 45, mostly you will be a middle-aged. And 45 to 60, you can say it's a pre-retired stage. And 60 plus, you can say that retired. Correct? So if you are a student, suppose if I'm a bank, so what kind of a bank you can, bank products you can offer? For a student, what can you offer? Maybe a student loan, or you can offer, sometimes you can also offer what? A saving account or a debit card. These are the typical products you can offer to the students. And if you are a started employment, what is the typical thing you can do that? Maybe you can do that a salary account and a credit card, or maybe a personal loan. And if you are a married stage, what is the typical products you can offer for them? Like, for example, home loan is not yet in the 24 to 30. Generally, you don't really see your future. You will always look at maybe a two-wheeler loan, or even car also. Sometimes you take maybe car loan, or maybe mostly a marriage loans, or maybe you can take honeymoon loans, right? So these are the typical loans, typical products you can offer. If you are a started family, so this is the place very common people will look for car, because your kid is going to travel in your car. right? That's what you want. You want to give a more comfort to your kids. And maybe sometimes you also want to do some kind of systematic investment plan, like you want to do some kind of a mutual funds or maybe some pension plan, some kind of a thing, so that uh, not pension plan, I mean more for a kid's perspective, you will do some kind of saving for a long term perspective, or maybe some health insurance. This is our typical products which you will offer. If it is a middle age, a lot of times you will start looking for the house, because you want to settle down somewhere. These are house loans, and sometimes you also want to do some kind of a long-term investments, like a 10 to 15 years kind of investments. So this is the typical thing. In the pre-retired stage, a lot of times, you will keep balances like FDs, cash deposits, fixed deposits, whatever. And I was referring that, or maybe you take some kind of a liquid funds, which is not saving account, but sometimes they will offer different accounts where you can get a little higher interest rate. So this is the kind of a products which you will spend more, because there you have some kind of medical emergencies, there you need some more money for your kids' education, etc. So you will use some kind of a liquefy quickly kind of a products. And retired stage, you will always maintain the balances, sufficient balances, or whichever products will give you the interest in a monthly basis. That kind of a products you will offer. Am I correct or not? A simple example is, based on the age, I am dividing the segments, customers into segments, and for each segment, I am offering a different kind of products. Why? Because that is the behavior of the customer. Okay, if I offer a home loan to student, does it make sense? Right? Or maybe a marriage loan or honeymoon loan to student, does it make sense? Or maybe honeymoon loan to a retired person will make sense? No, right? So a simple example, I'm saying that. So again, this segment can be a little more better fine-tuned if I combine with the gender, because the marriage age for a males, it could be a 28 to 32. A marriage age for a woman is a 25 to 30. This is the range, right? So that gender itself is a fine-tuning the segments. And again, the location. So the location is, for example, if the location is in urban versus rural, if I take it, the males will get married. Males will get married maybe in the urban areas a little late, but whereas a rural, they will get married little early. So maybe at least 3-4 years you can see a difference. The same thing applicable to women also. So that means I can get a little better, more, the fine-tuning segments, so that I can target more appropriately. Right. So that is what exactly I was referring that. So if I use these variables and coming up with the segments, and that segments can be used for targeting different type of products, or a cross-sell, upsell, or identify the characteristics. So this is what we call it as a life stage segmentation. Am I using any scientific method here? No, right? It's a purely business sense, common sense. This is what I'm using it. Right? So are you clear now what is the life stage segmentation means? Okay. And the other type of segmentation, which is very common in the market and especially all customer service industries, is RFM segmentation. So R, F, and M. Of course, this is initially started with the retail industry, but this is extended to every industry now. Okay, but yes, the customer service industries or customer centric industry is very commonly used. So R is nothing but the recency. F is nothing but frequency and monitoring. So what is the recency? Recency is nothing but a number of days from a last interaction. It can be a transaction. Okay. Frequency means a number of times interacted, number of transactions in a specific period of time. So I mean to say that the last 6 months. A number of, not number, the total revenue or a profit generated in a specific period of time. This is basically a last maybe 6 months. In the last 6 months, what is the revenue generated by each customer? So based on these three variables, I can come up with some segmentation. That is what we call as a RFM segmentations. R is nothing but the recency, which is a number of days from the last transaction. And F is nothing but frequency, the number of transactions in a specific period of time. And M is a monetary value. Specifically, generally we talk about revenue, but some situations you may think about other type of metric, but very commonly take is revenue or profit. So the revenue or profit generated in a specific period of time. So this is what the RFM segmentation. So if R is high, what does that mean? If R is high, what does that mean? Sorry? Customer?
Inactives.
Is not into regular transactions.
Yeah, so if the R is high, is more inactive. Correct, inactive, the number of days are inactive. Right, if R is high, there is a possibility of that customer becoming churner. Correct. R is low, that means they're active. And F, what is the frequency? The frequency is high, what does that mean? They're more active. Active customer, more regular, right? More frequent, right? M is high. What does that mean? There are high revenue generators, right? So based on these three, we generally come up with a different type of segmentation. So typically my data will be something like this: a customer ID and a recency, frequency, and monetary. So like, for example, 1, 2, 3, 4, 5, 6, and so on. So the recency, maybe a 10 days, 20 days, 15 days, and 29 days, 32 days, 11 days, something like that. And the frequency is nothing but, okay, in the last 6 months he visited 3 times. In last 6 months, the second customers, done 7 times. 7 frequency means 7 purchases he made, and 3 purchases he made, 2 purchases made, 1 purchase made, 10 purchases made. Monetary, though he done 3 purchases, but he generated revenue of 10,000. And though these guys made 7 purchases, but he made only a 6,000 revenue. And these guys 1,000 revenue. And this is 12,000 revenue. This is 1,200 revenue. And this is 1,500 revenue. So it doesn't mean that someone is frequently visited. That means that they are spending more. Some customers, they will come, once in a month, maybe they will purchase more. But some customers, they frequently purchase, but they will purchase less. Right? So this is the typical data. You will get it for a customer level, and based on this, you will come up with a segmentation. So a typical segmentation generally we do is, of course, a lot of times, just like a value-based segmentation, you will have a cutoffs, right? So the cutoff is okay, greater than 10, greater than, between 5 to 10, less than 5, something like that. You can divide the R, and you can come up with a segment. And similarly, frequency also, a greater than 6 frequency, I'm calling as a high, and a medium or low. Or M also, I can come up with a different cutoffs, and I can say that. So if you have a business cutoffs, I can use that cutoffs and come up with the segments for each, and then using those 3 segments, you can come up with a final segmentation. But sometimes, if you don't know that cutoffs, what will you do? It is similarly what we have done in the value-based segmentation, like a quartiles or something like that you can take. So for example, if I take a quartiles, okay, R segments and F segment and M segment, what we can do? R segment means what? Recency segment. You know, you are dividing the data into 4 groups, something like that. Okay, just I'm giving random numbers. Don't get confused with this value and this value. And F also you will have. Sorry. Something like that you have. So that means that in this case, for example, if you get the segments like this, if R is high, that means the R segment is high. So what does that mean? They are having a high inactive. If probably what we can do is, you know, based on the R, I can call it as a, okay, if 1 is there, they are more active customers. If 3 is there, at 3 and 2 and 3 I'm calling as a at risk. Why I'm calling as at risk? They are inactive for some time. If we don't take care, probably they will churn. There is high possibility of churners. If we, you know, for example, you know, 2 means at risk, and 1 means active, 4 means risk. I mean, risk means churners, correct? Or maybe I can say that risk only, risk or maybe churners. And this is 2 means so at risk for right. I can do this kind of segment. And then FM segment means what? So where frequency is high and monetary is high. So if both frequency is high and monetary is high, for example, here also 4, here also 4, and those customers I can call them as a very good customers, right? So for example, in my frequency is high, you know, maybe 1, 2, 3, 4. Okay, my monetary, you know, 1, 2, 3, 4. Maybe if both frequency and monetary is high, and those customers are very good customers, probably I can call them as a, these guys called as a platinum customers, for example. And maybe one of them is high and other them is low. So like for example, this one, maybe this one, probably I will call it as a gold customers. Or maybe this one, I call it as a silver customers. And these customers I can call it as a what? Standard customers. So probably these customers I can say gold.